The people are joining, sir. Around 65 people will join, sir.
Fine. Okay. Say, the thing is, this is actually normally I will not speak any theory kind of things. And what I experienced in my career since 2009, because I started my educational research in 2009, and I got opportunity to work in National Board of Accreditation, New Delhi, to develop the standards for our country to become signatory member in Washington Accord, and the self-assessment report, what you have been seeing and you are filling, that the first report, that format and the assessment guidelines and the rubrics and tier 1, tier 2 manuals and all the things were developed by a team of 5 members, and I'm one among 5 who led the team. So here my topic is something actually the why CDIO when outcome-based education, OBE is, or why CDIO is required when outcome-based education. Say this is not the conventional way of what to say the presentation, in the sense actually you cannot learn anything from me, I would say, before start my session. So the thing is here, my intention, my outcome, what outcome I set in the sense, at the end of the session, the participants who have been attending this session should actually think in different direction about the engineering education and the outcome-based education philosophy, outcome-based accreditation, and different education models, and why we are going to, why it is required to transform the what do you call the academic process or the curriculum design or teaching learning, or what do you call, I would say, this assessment and evaluation. So my intention is actually not to give the stuff, and on the other hand, my intention is to make you to think. That is the basic idea behind this presentation. And I would like to share my screen. And this also can, and for better clarity, I can also this one. This is. I think my screen is visible.
Yes, sir. It is visible, sir.
Fine. And these things actually I have to know. That's right, and I can keep something here. Why it went out and upwards. Okay, fine. Yes. So here the title, are you seeing the title? Something this is hiding, and I cannot. I'm trying to move this one, or if I escape, no. The button. Sharing. Can I hide the screen? Screen is sharing, right? Okay. I cannot hide the screen. Okay. Somewhere it will be. Okay, fine. I did. Say, we all know very well, NBA, National Board of Accreditation, became permanent signatory member in Washington Accord in 2014 in the meeting which was held at Wellington, New Zealand. And India became National Board of Accreditation, New Delhi, became provisional member in Washington Accord in the year 2007. Since then, actually, in India, in engineering institutions, we have been talking about the outcome-based education, like the different jargons, program education objectives, program outcomes, course learning outcomes, student learning outcomes. So many things we have been talking and discussing. And if you see the manual or the self-assessment report. There also again the attainment of course outcomes, measuring the attainment of program outcomes, graduate attributes, program specific outcomes. Then if you ask me different jargons, but if you ask me honestly, having visited so many institutions in this country, I would say in India, the present status of the outcome-based education, even since 2007, if you see, the outcome-based education is only on the paper. Here, we are not really practicing the outcome-based education. Here, I would say it is the outcome structure. In the sense, if you refer the curriculum of any program of any institute, they will say, yes, sir, ours is BE mechanical engineering or BE computer science and engineering. You can see our department actually has vision and mission. And if you see the computer science and engineering program has program education objectives, program outcomes, you see, sir. And these are all the list of courses in the curriculum. And you can take this course, say compiler design or the artificial intelligence, or you can take the network or any course. That these are all the course outcomes, sir. And these are all the methods we are following. Like this, they will explain so many things. And they will tell, sir, you see the CO mapping, sir. They see it's a higher level, high level, low level. All the stories we will explain. But if you ask me, those things are only on the paper. No faculty member is following the outcome-based education with the true spirit, and no way the outcome-based education is useful for the faculty members as well as the students. That is a real scenario. So I would say this outcome-based education in India it is not the outcome-based, it is the outcome structure. And in the sense, the outcome-based education is not in practice, only on the paper. And I cannot say all the institutions. There are some institutions where without actually writing the outcomes and all, they have set their outcomes and they are delivering the course. They are assessing the students with respect to the outcomes. In the sense, they did not document. Many of the institutions, they are doing the documentation, but they are not practicing. But other institutions, they are practicing, but they are not documenting. Say example, some institutions, if you say, I'm not telling all the professors in IIT or the NIT or any institutes of national importance, it depends upon the professor, and the students actually, their knowledge level, their skills, and their problem analysis or the problem solving, or I would say the communication skill or the modern tool usage, whatever it may be, and they are good in the sense actually not documenting anything. Say here you forget about the input quality and output quality, other things. What I'm trying to say, they are also doing the educational process or the academic process, but not documenting anything. They are trying to impart the knowledge and skills. So that is also not correct. So I would say the education is outcome based, but actually it is not on the paper. And if you see why it should be on the paper, once if it is documented, then only it will become it will become the process oriented. Otherwise, it will become the person based or the teacher centered. And in India, without implementing the outcome based education, the institutions, the educational institutions in this country, they are going for NBA accreditation. We all know very well. Many institutions, tier 1 institutions, like the programs in the central universities or the state universities or the government colleges or the autonomous colleges and the self-financing colleges. So many programs went for NBA accreditation, and they received accreditation also for the period of 3 years or 6 years. Say, not implementing the outcome-based education, how it comes possible for the institutions to get the NBA accreditation? It is a big shock. But say, what is happening? They are presenting the data from one format to another format for the purpose of accreditation. Here, what does it mean? They have their own traditional educational process or accreditation, what do you call the academic process. They're actually the conventional way. But if you see, the paper, all the things actually they will measure the attainment of the course outcomes, they will articulate the course outcomes, they will write the knowledge level using the Bloom's taxonomy keywords, K1, K2, K3, K4, and so on. Say the remembering, understanding, applying, and again the Dave's taxonomy for the skill domain and the Bloom's taxonomy for affective domain. All the things they will write, they will measure, they will do big calculations using the spreadsheets and everything. Finally, if you see, so the MBA experts, they will come and see, verify, they will interact with the faculty members, and they will explain, we have done the mapping like this, and this CO, this PO, and the level this. So the attainment, this is a calculation, the attainment level is 98%, or in the scale of 3, it is 2.7 or 2.8. Likewise, we are telling something and we are convincing. But if you ask me, it is only we are doing, we are practicing the traditional way of delivering the things and assessing, but we are presenting the data, the same data from one format to another format, which is required for the accreditation. So I would say here, no institution, no, I cannot say no. So I would say the more than 90% of the institutions are not following the outcome-based education, though albeit they got the accreditation. And yes. So let us see. Here the title is Why CDIO. The C means conceive, D means design, I means implement, O means operate. Why CDIO when outcome-based education is? Here let us see the evolution of engineering education. Evolution of engineering. This is what is it? The book in 1855 and 1856. This is called the Engineers Contractors Pocket Book. There actually, if you see the pages, the first 30 pages are calendar, and if you see the some pages, I can read in this page the what is a boxed. So the boxed content I am reading. Table exhibiting the strongest forms and best proportions of riveted joints as deduced from the experiments and actual practice. If you see the table caption here, engineering is not the theory, engineering is the practice. So what they practiced here, if you see the riveted joints as deduced from the experiments and the actual practice, the best proportions. Say forms and the best proportions of the riveted joints as deduced from the experiments and practice, in the sense actually they from the practice what they experience, what they observed, and they are putting in the what do you call the text. So here engineering is not the theory, it is practice in during 1850s. We can see the European engineering education. Say the British more empirical oriented, and the French more rationalistic. And if you see the technical training shifted from apprenticeship to the university education. But in Russia, actually, there you can see their influence, the what to say, French. Why this is actually, this is hiding the what I can, where I can keep. This is can I okay, let me be. So if you see the development of engineering education in Russia, say there actually you can see the French domination. So why, what is the problem? You are sharing back to top. No, this is not convenient. This is actually, it is troubling me, but it is obstructing your view also. So here you can see the number of engineering students in US between 1900 and 1930. for electrical engineering, mechanical engineering, and the chemical engineering. So in thousands, say it started from 2000, 3000, and 1000, and so on, and up to some 16,000 at the electrical engineering approximately, and the mechanical engineering around 10,000, and so on. Say until 1930, these are all the number of engineering students in United States, and the engineering education pendulum, if you see, empirical practice in 1920s, and if you see the science engineering science-based education, say in 1920s actually the practice dominated, and if you move between 1930 and 1945, that is the Second World War happened between 1939 and 1945. Say if you see, just a minute, I have some important call. I must respond to a call. And sorry, some important call. And if you see the engineering education between 1975 and 1990, there actually, which dominated? The science dominated. Say, previously the practice dominated during Second World War, science and practice together, and 1990s, if you see, the science dominated. And you can see, yes, 1950, see, x-axis, if you, we can see the analytical skills, disciplinary knowledge, and the theory. And the y-axis, Thomas Alva Edison, there actually innovation, implementation, collaboration, skills, and practice. So what does it mean? Say, there are two different views during the period 1840s, 1931, and here also the 1930s, 1963. Say, if you see, it is during a Second World, before Second World War, and during and afterwards, the engineering was understood like this. Engineering means innovation. Engineering means implementation. Engineering means collaboration, skills, practice. That is the meaning of engineering. The same time, you can see the definition by Theodor von Karman. What he is saying, he is a mathematician, and later he has done a significant work in the aeronautical. What he is telling, the analytical skills, disciplinary knowledge, and theory. Say, these two are the opposite views, but in 1950s, in engineering, practice dominated, and 1960s, science entered, and the practice started decreasing. The y-axis, you see, the y-axis started decreasing, and the x-axis started increasing. Say the x-axis actually, again, 1980, after 1980s, then you can see the science only dominated in engineering. There is no much practice, and there is no collaboration skills, no implementation part or innovation part. So here, this is how the engineering education got evolved internationally. And I request you to remember this graph, because this is the basic reason how the CDAO was born. So this is the reason, because in engineering the practice completely has gone. So to bring the practice to back to the engineering, what actually the forum or the worldwide initiative started by the 4 institutions, that is called the CDAO initiative, that we will discuss later. Say here the problem is the science dominated. Because of this, when students acquire the knowledge and some skills, there actually the practice has completely gone. So of course the disciplinary knowledge is very important, whether it is a basic knowledge or advanced knowledge. But at the same time, engineering means, actually I have shown one book, actually the contractors handbook there clearly mentioned. So what engineers what engineers should do, they have actually done the experiments, and they from the practice they documented the things. So the practice is very, very vital, and how it has been realized. And you can see this is the one side, the evolution of engineering education. Now let us come to the education philosophy. What is OBE? Outcome-based education is the education philosophy. So there is no actually, if you go through the web or any textbook or any research paper, so normally the author Spady, he is the one who is known for the outcome-based education. But before Spady, I could see some materials, some research materials. There is a Johnson City model, a well-established example of outcome-based education in actual use is the Johnson City. What is the name of the model? Outcomes Driven Development Model, ODDM, was launched in the year early 1970s. Actually, we have been talking about the outcome-based education after 1990, but in early 1970, there was a model which was launched, ODDM, Outcomes Driven Development Model. Say there actually they implemented, and they brought some changes in the pedagogy as well as the assessment and so on. And in 1991, Spady and Marshall, they used the traditional OBE for the OBE programs. Here, what does it mean? They are focusing on the mastery level. We all know very well the mastery level. Through outcome-based education, we have to make all the students to reach the mastery level which is defined. So outcome statements are nothing but the nothing but the abilities in terms of knowledge, skills, and attitude, and we have to set the bar. So the bar is nothing but mastery, and we have to facilitate all the students to reach the mastery level. That is a Spady and the Marshall. And the third one, if you see the MEC-REL, this is actually Mid-Continent Regional Educational Laboratory. They started, actually they realized that the assessments are very, very important. The model involves writing performance tasks that specifically include elements of several different outcomes in one challenging task. Actually, here nothing but here task means task may be if you give the problem to solve the problem may be the task, and if we give the assignment, that may be the task. If we give some kind of project work, and that may be the task, whatever may be. Through one task, we can achieve so many outcomes, or so many outcomes will address can be addressed through one specific task. It depends upon the nature of task. If the task is at the very high complexity level, then it may address so many outcomes. So in 1993, this Mid-Continent Regional Education Laboratory, they told actually the assessment is very, very important with respect to this outcome-based education. And this is I have taken from the Wikipedia how in the different countries this outcome-based education entered and dominated and played different roles. And if you see the Australia and South Africa in the year between 1990 and 2000, and the United States 1994 and 2005, Hong Kong adopted OBE. Malaysia, they are telling my OBE in 2008, and Europe also after 1996 they started implementing OBE. And the Washington Accord, we all know very well. The apex body for engineering is the International Engineering Alliance. Under International Engineering Alliance, there are different accords: Washington Accord, Sydney Accord, and the Dublin Accord. The Washington Accord is primarily responsible for undergraduate engineering programs, and the Dublin Accord is for the diploma, and the Sydney Accord is for the ITA, the technologists. So here in 1989, the Washington Accord was created to enhance the mobility of the students and the mutual by a mutual agreement of their academic awards or the degrees. Say the Washington Accord insisted the member countries to follow the outcome-based education. In India became the member in Washington Accord in 2014 by adopting the outcome-based accreditation parameters to assess the quality of the program. We all know very well. Until today, we have been following. And this membership got renewed in the year 2020. And we are enjoying the status of Washington Accord because in our country, we have been following the outcome-based accreditation process. And so many member countries, you can see at the bottom. Fine. This is the evolution of OBE. First, what I told, the evolution of engineering education. So from 1800 to 1980, from practice to engineering science and science. And next, the evolution of the outcome-based education. This is not a comprehensive. What I discussed in the evolution, that is not the comprehensive or the complete. This is for sample and the different countries and the different institutions, how they started implementing, when they started implementing the outcome-based education. And this is a very standard, what do you call, the framework. And the left-hand side, the left top, you can see the mission, program educational objectives, program learning outcomes, course learning outcomes, CLOs. What does it mean? Yeah, because all the participants, definitely you might be knowing program educational in NBA, CAR, if you see the department which is offering the engineering program should have the vision and the mission. And how many programs are offered? Maybe one department, there may be several undergraduate programs and several postgraduate programs. So each program should have the well-defined objectives called program educational objectives. So what does it mean? Program educational objectives are the statements what our graduates will achieve within few years of graduation. That is nothing but PEO. Say after graduation, say now 2020, students are graduated, and within 2023, 2025, what they will achieve. We have to tell in advance when they are joining. When they are joining the program, we have to tell what you will achieve after graduation. Those statements are nothing but promising statements or some assurances we are giving to the students. So the PEOs, the program educational objectives, are the statements which will help the students to clearly understand what they want to be in their career, what they want to achieve in their career. So then the program outcomes or the program learning outcomes means to achieve the program educational objectives, students actually should have the abilities in terms of knowledge, skill, and attitude, cognitive domain, psychomotor domain, and affective domain. These abilities are called the program outcomes. We all know very well the Washington Accord graduate attributes. Internationally, there are 12 graduate attributes for undergraduate engineering students. The 12 graduate attributes are nothing but the program outcome statements. The graduate attributes are generic in nature. The graduate attributes are not specific to one particular program. It is for common for all the engineering program. And if you want to customize the graduate attributes to one specific program, you can customize your mechanical engineering or electrical and electronics engineering or electronics and communication engineering. We can customize. They are generic in nature, like engineering knowledge, problem analysis, design and development of solution, investigation of complex engineering problems, modern tool usage. These 4 or 5 are related to the professional competencies, and the remaining part, if you see the graduate attributes, the second, some 5 or 6 graduate attributes, they are more on the transferable skills like teamwork, communication skills, lifelong learning, and the project management and the finance, self-learning. So these are engineers and society. So the program learning, program outcomes, these are all at the end of the definition. If you see at the end of 4th year, what the graduates will demonstrate, or I would say what the graduates will do upon completion of the program, or what abilities or the graduates should be able to do what, that we need to tell very clearly, right? These statements are called the program outcomes. Upon completion of the program, what the graduates will do. And the course learning outcomes. The course outcomes actually to achieve the program outcomes, we should have the curriculum. So curriculum is nothing but the list of courses. Each course will have the outcome statement, means upon successful completion of the course, what the students will do, what the students will know and able to do. So we need to clearly tell. Those statements are called course outcomes. So this is the first quadrant, and you can see, and here the course syllabus, pedagogies, learning process, and assessments. Say if your program is outcome-based program, then it should have the mission, vision, PEOs, POs, COs. Then for this, you should have the course syllabus and how you are going to deliver the content in the syllabus. Then how you are going to do the assessment, the course level assessment, program level assessment, then the institute level assessment. Then coming to this, after making the assessment, then we need to see whether the outcomes are attained or not. If the outcomes are not attained, we need to review the program completely, where the problem is, what is the reason we could not attain the set outcomes to the set level. Then example, so the program outcome, if you are setting the program outcome, the problem analysis to 85%, but only you have attained only the 75%. Why not 85? What is the difference? The reason we need to identify whether the problem is with the curriculum, whether the problem is in the teaching learning process, whether the problem is in the assessment and evaluation, or whether the problem is in the course learning outcome, or some more topics to be added, or some topics to be removed, or some kind of hands-on practice should be given to the students. Something we need to identify the cause. So we have to identify the ways and means to improve the attainment of the outcome. Ultimately, and here if you see, this is a complete cycle: plan, do, check, act. Say plan is nothing but defining, articulating all the things, nothing but planning, doing. So imparting the knowledge, skills, and attitude to the students, or facilitating the students to learn the things or to acquire the things, and check at what extent they acquire the things, we are checking, and finally we are acting. Based on the assessment, we are trying to bring the improvement in the system, that is called the continuous improvement. Say this is not my original diagram. This is actually lot of diagrams are available in the website to represent the OBE framework. So I don't want to waste my time. So I have taken and I'm trying to explain. And this is also another one. Here also you can see the left hand side, the outcomes column. If you see the outcomes column, the institutional mission, and from the institutional mission, the program education objective statements, then program outcome statements, then the course outcome statements. The course outcomes will help to achieve the program outcome, and the program outcomes will help to achieve the program objectives, and in subsequently the institution and the department vision and the mission, and finally the institute mission will be achieved. The course outcomes, if you see, we have the syllabus, teaching methods, learning activities, and assessment. Then we are measuring that after assessment, course level assessment, program level assessment, institute level assessment. We are trying to bring the improvement. All are same, but these are all the different ways of representation. And for the articulation, left hand side, if you see we are getting the input from various stakeholders like industry people, alumni, parents, or student employers, all the faculty members, present students. So we need to get the input from various stakeholders. And here for doing the assessment also, we are getting the input from the various stakeholders. So in the sense, normally we used to keep the people in the board of studies, academic council, some kind of advisory committee in the program. So this is the general OBE structure, right? Now the question is, sir, OBE, why we have to implement outcome-based education? Whether any problem in the existing education? Why people are telling outcome? Say, I'm telling there is no problem in the existing education, existing method. The traditional process is very good. But the thing is, any system will have a scope for continuous improvement. If you see this kind of outcome-based education, here we are articulating everything well in advance, and we are designing the process, whether the process is the curriculum design process or the teaching learning process or the assessment, whatever it is, all the things are aligned with the outcome. So the students as well as the faculty members we all come to know what is to be achieved. So ultimately, students should attain the outcome, and the faculty should facilitate the students to attain the outcome, or like a guide, we have to help the students to attain the outcome. Say here, otherwise the thing is, okay, sir, without also we can do. But if you want to really assure the quality of your program, you have to go for third-party assessment by the different agencies, maybe the government or what is it, the private. Say, if you see the in India to get the accreditation, we have to go for getting the program accreditation. We have to go to NBA. If you see the NBA document, there they are asking the program educational objectives, program outcomes, course outcomes, mapping of course outcomes with the program outcomes, and attainment of CO, attainment of PO, all the things. Say even NAC accreditation, it is an institutional accreditation. Recently, our university received A plus last February. We got A plus. It is a second highest grade. A double plus, next A plus. Actually, I did the things. There also they are insisting the programs offered in the university should follow the outcome-based education. Even if you see the UGC, University Grants Commission, their quality mandate, they are also insisting the programs offered in the any institutions should have the LOCF, Learning Outcome Based Curricular Framework, LOCF. So whatever may be the accreditation agency, even Accreditation Board of Engineering and Technology, long back they introduced the outcome-based education, because US has started implementing this outcome-based education some 4 decades before. And IET, Institute of Engineering and Technology, it is UK-based accreditation. They are also following the same. AICSB, it is for the management program. They are also following the outcome based. And the AMBA, Association of MBAs. So here just I mentioned very few, but wherever you go, all the accreditation agencies, they are insisting your program must follow the outcome-based education. In the sense, should have the vision, mission, POs, COs, and measuring the attainment of COs, POs, all the things they are expecting. And your curriculum must be designed based on the outcomes. So whether we like it or not, the institution to survive must adopt the outcome-based education philosophy, and they have to implement the things in their academic process and the educational process to produce good graduates. And before outcome-based education, what these accreditation agencies did, let us see, they have the different system of accreditation called the input-output based accreditation. There actually they will measure the input parameters like, do you have the adequate infrastructure, whether your admission students quality, and the faculty and the student faculty ratio, faculty qualifications, faculty research publications, and these things only they will see. And the output parameters, how many students graduated, successfully graduated, their percentage, all the things. They will not directly measure the knowledge, skills, and attitude. So this is actually the traditional, but till today we are following the traditional only. We are really not following the outcome-based education. If we follow the outcome-based education, our student mark sheet or the profile should be different. It should look like the 12 graduate attributes. What is the attainment of the individual student in each graduate attribute, and the program specific outcome. We have to mention in terms of 5-point scale or 3-point scale or in terms of percentage, but it is not the case. We are riding on the two horses. One is the outcome-based education. It is exclusively for accreditation purpose. Another one is the traditional way of doing the things. It is for our survivability. We don't want to change the traditional. We don't want to change our process from traditional to outcome-based. So this is the problem. And in outcome-based, what is happening? We are measuring the students' knowledge, skills, and the behavior, and accordingly, we are trying to bring the changes in the educational program. We are trying to tune the program. This is actually the outcome-based. Based on this, the quality of the program is assessed by the accreditation agencies. These are all the different steps in the outcome-based education, and This is based on my understanding. I put this slide, and we need to, if you are telling your program is the outcome-based program, then you have to define the outcomes for the program. Say outcomes means program outcomes you have to define. Then we have to design the curriculum based on the program outcomes. So once if you design the curriculum, then each course in the curriculum should have the course outcomes. So we have to design the curriculum according to program outcomes. After designing the curriculum, we have to deliver the instruction. Same means actually we have to impart the knowledge and skills to the students, or facilitating the students to learn the things or acquire the things, and devise the assessment. So once the instruction is done, we need to devise the mechanisms or the assessment tools to measure the attainment of students, to measure the attainment of the different outcomes, I would say, otherwise to measure the students' knowledge, skills, and attitude. Then we need to document the results and go for the continuous improvement of the advancements in the program. And this in outcome-based education, the first step, what I told, we need to define the outcome. Say, to bring the commonality in the international level, International Engineering Alliance insisted Washington Accord to define the graduate attributes. Say, graduate attributes are nothing but the outcome statement, what our graduates should know and be able to do upon completion of the 4-year degree program. What they will do, we have to clearly tell. And moreover, these are all the very minimum. Say 12 graduate attributes, if you see, engineering knowledge, problem analysis, design and design and development of solutions, and so on, and communication, lifelong learning, individual and teamwork, ethics, and so on. Say, the next slide will help you to understand the engineering knowledge, problem analysis, design, development of solutions, conduct investigation of complex problems. These 4 are bigger in size and equal in the sense these 4 are graduate attributes contribute almost 70 to 80% in the sense these are all nothing but the professional competencies and professional skills. So what I'm trying to convey, say this will occupy the major area in the screen, and remaining, if you see the modern tool usage, the engineers and society, ethics and environment, these are all the next smaller size. And further, if you see the individual teamwork, communication, then the project management and the finance, lifelong learning, these are all the next level. Say here, what I want to communicate, the graduate attribute, all the 12 graduate attributes will not contribute the same percentage, will not, all the graduate attributes will not have the equal distribution, I would say. So in when we are serving the full meal, salt, the pinch of salt will be, and if you see the curry, the vegetable curry, it will be the small quantity, and the rice will be the higher amount, sweet will be very less, and pickle is still further less, and something, if you see the distribution, there will be different, but everything is important. Salt is important, even it is very small in quantity. So far I'm telling the graduate attributes from engineering knowledge to lifelong learning of the project management and finance. These are all essential attributes for any engineering graduate, but need not to contribute the same percentage. So why I'm insisting, while designing the program, we should take care of the things, how much importance should be given for the engineering knowledge and the lifelong learning or communication skills, right? So you have to design your program based on your students' abilities and the faculty resources and all the things. Say, the next question is very important. So whether the GS maximum or minimum, there are 12 graduate attributes. As per Washington Accord clearly described 12 graduate attributes. Whether these graduate attributes are maximum or minimum, these are all minimum. Here, if you see the different water bottles, the Bisleri, Kinley, Aquafina, Himalayan, Bailey, something, Kingfisher, Tata Water Plus. These all are ISI certified. all the waters are ISI certified. Then what is the difference? Say difference actually, why here to get the ISI certification, the water quality should fulfill the minimum things. So since all the 6 or 7 waters fulfilled the minimum requirements, so all waters are certified as by ISI. And over and above the minimum requirement, distillery may have additional quality, maybe the different additional some minerals or nutrients, I don't know. And Aquafina may have something different. So since all the waters fulfilled the minimum requirement, ISI gave the certification to all the water, but all are not the same price and all are not in the same taste. The different water will have the different taste, but ISI certified. So far I am telling, graduate attributes are minimum. The 12 graduate attributes, the each and every word in the graduate attribute is very, very important. We cannot omit. For that matter, only one example I am telling, complex engineering problem. The word complex, if you miss, then the complete statement will become wrong and that will not be accepted by the accreditation agency. Here the complex problem, what is the difference between the ordinary problem and the complex problem? Complex problem should fulfill the requirement of Washington Accord problem definition, WP1 and WP2, WP3 and so on. Again, it should fulfill the requirement of Washington Accord knowledge profile, WK1, WK2 and so on. And that problem should not have a single solution. And the problem should not be defined very clearly and it should be ill-defined. So there are different qualities of the complex problem. If you omit the word complex in the first statement, engineering knowledge, students should be able to apply the knowledge of mathematics there, blah, 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 to solve the complex engineering problem. If you omit the word complex, then your program will lose its relevance and your program will not deserve for accreditation. So far, I am insisting these graduate attributes are very, very minimum. We cannot miss even a single word in the graduate attribute. These are all, I would say, succinct. Succinct means like our Kaprat's Tirikural. If you miss one word in the 7 word, then that will convey the different meaning, or it will lose its what you call the I would say the intensity. So the minimum, the how to actually the water, one water say example, Kinley does not fulfill the requirement of ISI, then it will not be certified. Similarly, if you miss even a single word, say even the individual or teamwork or communication skills or the project management or lifelong learning or ethics or education, society, environment, sustainability, modern usage, whatever it is, if you miss single thing, and if your program does not, if your program curriculum does not fulfill, does not help the students to achieve these, what do you call the 12 graduate attributes, and your teaching learning process is not aligned with the attainment of these program outcomes, then your program will not deserve for accreditation. So these are all very minimum. And if you see the this pyramid, and we know the top down, if you travel from vision and mission to the course outcome top down, then it is nothing but the design. If you travel from bottom to top, nothing but assessment. Say we all know very well the each department offering the different programs will have the vision and the mission, and the PEOs I told already, program outcomes I told already, course outcomes I told, and the PSC, program specific criteria. And one thing I forgot to say, in India they will tell program in addition to the graduate attributes, and each program can write 2 to 4 program specific outcomes, because in India only we are doing like this, in the sense actually keeping the 12 graduate attributes common, and we are trying to articulate 2 to 4 program 2 to 4 outcomes which are specific to one particular discipline, either mechanical or electrical and so on, and we are trying to map the course outcomes with the program outcomes. So those outcomes are called program specific outcomes. And here PSC is nothing but program specific criteria. It is different from program outcomes, because internationally to fulfill the minimum common things. Say, what are all the components which are to be kept in the curriculum? Say, so certain things should be, certain things must be common, minimum. Say, if you see the curriculum of Massachusetts undergraduate program and our IIT, same example, computer science and engineering, or you can take the traditional engineering program like civil engineering. The civil engineering of Massachusetts and IIT or NIT or some private college or what do you call some state university, Anna University or any government college, there should be some common. Means at least 50% of the curriculum or the course content should be common. So the program specific criteria tells two things. One, the program curriculum. Another one is the faculty competency. Who will tell the program specific criteria? The professional societies like IEEE, CSAB, ACM, American Society for Mechanical Engineers, American Society for Electrical Engineers, American Society. There are different societies for the professionals. They are truly international. We all agree. We all know very well. So they defined what are all the mathematics to be studied by the engineering students. Say what the calculus or complex variables or transform techniques or numerical methods and so on. And with respect to the engineering discipline, what are the minimum things for the mechanical engineering? The American Society for Mechanical Engineering, ASME, will tell. So we have to refer the program specific criteria and the graduate attributes. We all know very well, common and the curriculum. We have to deliver the instruction, measure, and go for continuous improvement. So top down is nothing but the program design, and the bottom up is nothing but the program assessment. Say the correlation, this code we all know very well. So many years we have been seeing, which was developed initially by us, and COs, course outcomes, are large in numbers because for any program there may be some 40 or 50 courses. The course may be the purely theory course or purely practical course or theory plus practical integrated course or some kind of skill embedded course like personal skill or interpersonal skills embedded course, something. Each course will have the course outcomes. In the sense, the course outcomes are the statements which will tell what our graduates will achieve upon completion of the particular course. So nothing but the course outcome. So each course may have, in India, we are keeping 4 or 5 or 6 outcomes. Generally, in India, we have the practice of keeping 5 units or 5 modules in the each course, and each module may have the 1 course outcome or sometimes 2 course outcomes. So minimum 5 to maximum 7 or 8 sometimes we may keep. And the course outcomes will have the correlation with the graduate attributes. In the sense, the course outcome will contribute to achieve the graduate attributes, and these graduate attributes, GA, will have the correlation with the program educational objectives, PEO. PEOs are nothing but the statements what our graduates will achieve after graduation, within few years of graduation, 2 to 3 years of graduation, 3 to 4 years of graduation, and so on. And PSO means program specific outcome. I told specific to the program because GAs are minimum, GAs are generic in nature. So we are writing 1, 2 to 4 program specific outcomes, and ultimately the vision and the mission. All the things should be in the the axis of the cone. The axis of the cone, if you draw, so all the things will converge towards vision and mission of the department. Right. So then, what is the problem in the outcome-based education? Sir, it is well defined, all the things, program education objectives, program outcomes, and we are conducting the test. But this is my own, the assumption and understanding. Here, the outcome-based education is telling what to do in the program. Means what to do. Say, it is the outcome-based education. If you see, only the 12 graduate attributes. What the international, what Washington Accord has given, Washington Accord has given only the 12 graduate attributes. 12 graduate attributes, that's all. Remaining PO, CO, and all Washington Accord did not tell. Washington Accord told very clearly the students who are graduating from your program should have 1 to 12, should attain 1 to 12, should demonstrate 1 to 12. That's all. Say what do you want, you do in your program. How you are going to help the students to achieve, to attain this 1 to 12 graduate attributes, it is up to you. So it is not clearly telling what we should do in the program. That is completely missed in the outcome-based education. Say just NBA, National Board of Accreditation, having understood this thing, then they are telling you have to articulate PEO, CO, map, measure, and so on. But Washington Accord did not tell, or you have to do the things. Only the NBA is telling you have to do. You may tell why we have to do what Washington Accord is telling. No, if you want to become permanent member in Washington Accord, if you want to become a signatory member in Washington Accord, you should, develop the things like this. You must adopt all the 12 graduate attributes in your program. Then only you can go for NBA accreditation. Then NBA will become. Because you may tell, why NBA should become a member in Washington Accord? Say, now recently we all know very well, the students who are working in the Middle East and some other countries, if they don't have the degree from the degree certificate from the accredited program, then they cannot continue. They cannot work in their companies. Companies they sent out, because so this will enhance the student mobility. It assures the quality of the program. So far, NBA tried to become the member in Washington Accord, and we are also all the institutions which are offering the program to ensure our program quality. We are trying to get the NBA accreditation. So this is happening. No, just a minute. So I am in the online program. So if you want to say that the thing is, the 12 graduate attributes must be attained by each and every undergraduate student. So it is up to the program, up to the institution to design. So far I'm telling the first one, what graduates should know and be able to do. That it is telling in the broader sense. So far I have put the yellow line. Why I have put yellow? If I put the green means it is complete. Washington Accord is clearly telling, our National Board of Accreditation is clearly telling what graduates should know and be able to do. It is simply 12 statements. By seeing the 12 statements, what we can do in the program, what to do in the program, that is also, it is telling you must attain, you have to do good teaching learning process, you have to assess the things. Likewise, only it is telling. So again, the yellow only. And how to design the curriculum. They are telling you how to design the curriculum based on the outcomes. How to design the curriculum? Completely missed. So red. And how to deliver instruction and assess outcomes. So are they telling any method you have to assess the outcomes like this? You have to assess you have to measure like this? Nothing. So the OBE, the outcome-based education, if you see, these are all the missing links, or I would say the gray areas in the outcome-based education. Because of this, in India, the outcome-based education is only on the paper, and no institution, no faculty member comes forward to really implement the outcome-based education. Why I should, what I am going to do here? There is no recognition for the faculty member who is practicing the outcome-based education or implementing. Our institutions are also not insisting to really, so far I'm telling, it should percolate from top. They should insist, yes, outcome-based education. Here, the regulatory bodies, even without outcome-based education, we are getting accreditation. Why the institution will implement outcome-based education? Without also, it is possible to get the accreditation. So there is no compulsion. So, and moreover, if any faculty member out of his her own interest wants to implement the outcome-based education, okay, this is a good thing, I want to implement something, then they also don't like, because they don't have any clear-cut idea here how to design the curriculum. Some outcomes they are telling, the Bloom's taxonomy, Dave's taxonomy, Simpson taxonomy, Harrow's taxonomy, Devin's taxonomy, this taxonomy, that taxonomy. So why I should read? I don't have time to prepare for the class, and why I should spend more time to learn these kind of things. So these are all the issues in the existing outcome-based education. Then if you ask me, is there any solution to overcome or to connect the missing links or to make the clarity in the implementation of the outcome-based education? Yes, it is there. So what is the solution? That is CDIO: conceive, design, implement, and operate. So outcome-based education is the philosophy. If you ask me, OBE is the philosophy. It is not the framework. The philosophy, we need to decode and we have to develop the framework. Then only we can implement. So just by telling the philosophy, we are trying to implement how the individual here in India, we all know very well, the engineering education research is very, very poor. Research, I'm not telling the general technical research in image processing or thermodynamics or artificial intelligence or machine learning or augmented reality or virtual reality. I don't bother. But I am telling about the educational research, curriculum design, research in curriculum design, research in teaching learning process, pedagogy, andragogy, assessment, evaluation. These are team-based evaluation or rubric. Nothing. There is no educational research, especially in engineering education. Also, there is no research. So there is no educational research. So how the institutions will come to know, and the majority of the institutions are affiliated. They don't need to design the curriculum, and very few institutions are having the freedom to design their own curriculum, like central university, state private university, state government university, institutes of national importance, and some autonomous colleges. And these are all the institutions have the freedom of designing the curriculum. And other institutions, simply they are like coaching centers, what the affiliating university is prescribing, that only. And nowadays, no need to worry. AICTE itself is giving the curriculum. You no need to design your own curriculum, you follow the curriculum. Then why, how the things will happen? Say, if you want to produce the graduates to achieve these 1, 2, 3, 4, like PO statements within few years of graduation, accordingly, you have to design your curriculum. Accordingly, you need to design your instruction. Accordingly, you need to deliver the content. Accordingly, you need to plan your pedagogy or the instruction modes and methods to the students. And again, what do you call the assessment? All the things must be in line to achieve the program education objectives, but it is not happening. And the faculty members to really design the outcome-based education, to implement the outcome-based education philosophy. Outcome-based education is a philosophy. To for successful implementation of the outcome-based education, we should. Internet connection is unstable. Whether am I audible?
Yes, sir.
Is it audible?
Yes, sir.
Okay, connection is there. So if connection is lost, you tell me, because my side today, what you call the direct wire connection is not proper. So through Wi-Fi only, I am doing the things. So if there is any problem, immediately you please let me know through phone call.
Okay, for sure, sir.
Because normally I will forget. So when I started discussing the things.
Okay.
Fine.
Sir.
The CDIO is the framework. Let us see the history of CDIO and what are all the nuances in the CDIO or the components in the CDIO. Now, first we have discussed the evolution of engineering education from 1800 to 1980. Then next we have discussed the evolution of outcome-based education from 1970s to 2010. 2010 to till date, the evolution of outcome-based education. Now we are going to see the evolution of CDIO. In between, what we have seen, what are all the issues we are facing if we want to implement the outcome-based education, what are all the challenges ahead of us to implement the outcome-based education, vis-a-vis designing the curriculum, implement delivering the instruction, and making the assessment. And now we can see the CDIO is the solution I'm telling. How this will serve the purpose and help the institutions to implement the outcome-based education. And this is the worldwide initiative. As I told earlier, C is conceive, D is design, I means implement, O means operate. This initiative was started in the year 1997. You can see the left extreme 1997 by 4 institutions: MIT, Massachusetts Institute of Technology. Then I would say that Chalmers University of Technology, Sweden, where I went and interacted with them. Then Linköping, then KTH, Sweden, Royal Institute of Technology, Sweden. These 4 institutions are the original contributors, but the CDAO was born in MIT, but later it was actually developed by the 4 institutions together, 3 from Sweden, Europe, and 1 from US, MIT. Professor Edward Crawley from MIT and Professor Johan Malmquist from Chalmers University of Technology, and I would say Christiana. I'm working with them since 2012. I have been working with them, developing the engineering education, engineering curriculum, meeting them, interacting with them, and learning the CDAO philosophy, CDAO syllabus, CDAO standards, implementing, experimenting, sharing our experiences with others. This I have been doing since 2012. And today also the conference is going on. The CDAO conference is going on in Thailand, Chulalongkorn University. You can see from June 21st to June 26th, some 5-6 days conference is going on. Today also the conference. If you want, you can go and search in the web, and you will get the details of the CDAO conference. But to register, you have to pay much for attending the conference virtually. So you see the birth of the CDAO. It is 1997. But it was registered in the year 2000, the 4 universities, as I told earlier. And you can see the timeline, and up to 2015 only it is there. Now more than 200 universities are the member. Out of 200, more than 190 institutions are world-class institutes and the top-ranked institutions, ranked by Quackerly, Simons, QS, and Times Higher Education. So here, what does it mean? Here, what is the meaning of how it was born? How MIT identified, who motivated Professor Edward Crawley, who is the head of the aeronautical department in MIT, who is the driver? What are all the internal drivers? What are the external drivers to develop such kind of framework or the curricular framework for the engineering education? And let us see the drivers. This is the story behind the birth of the CDIO. Say, we all know very well the Boeing company, the aircraft manufacturing company, Boeing. Actually, the Boeing will go to MIT campus every year to recruit the students. There, actually, after recruiting the students were working in the Boeing company. But Boeing is not satisfied with the performance of the MIT students. We all know very well, Massachusetts Institute of Technology is the #1 engineering institute in the world. And if you see the international ranking, whether it is QS or Times Higher Education, always it will be in the top 3 or top 5. But there the aeronautical is the #1 in the world. But the students who graduated from the aeronautical department are not, what to say, are not fulfilling the requirement, are not the graduates did not deliver the expectations, did not fulfill the expectations of the Boeing company, the industry. There, then what happened, you know? Oh, they told the Professor Crawley, your students are lagging in this. We want students should work in a teams and ability to think both critically and creatively. And we want students should have the self-confidence and adapt to rapid change. And we want students should work in multidisciplinary teams. Say, likewise, they are telling so many things. Say, then the Crawley, he started thinking, oh, these attributes were articulated by you can Google and you will get the Boeing 1995 graduate attributes. And they told the professor, these are all the attributes which, the Boeing expected from your graduates. you please try to produce the graduates with these abilities, and you design your curriculum accordingly, you deliver the instruction accordingly. And Boeing gave the feedback to the MIT professor Edward Crowley. Then he started thinking, if my program is my students are not delivering, then who will deliver? What is the problem in my program? Then he started thinking, and what happened, then he identified something should be done. Then he identified the gap. The main goals of engineering education: to educate students who are able to master a deeper working knowledge of the technical fundamentals, lead in the creation and the operation of new products, process, and the systems, understand the importance and the strategic impact of research and technological development on society. The two scientists, actually, we can see here one. Here, I told, so I have shown one graph. Y-axis Thomas Alva Edison, x-axis Von Karman. Von Karman, actually, the disciplinary knowledge, analytical skills, he is telling, he is insisting. But Thomas Alva Edison is telling innovation, practice, collaboration skills, these are all required nothing but for engineers. So finally, this professor Edward Crowley, he understood these two are required. So the students, the engineering graduates should think like Von Karman and perform like Edison. So ready to engineer. So he started rethinking the engineering education. He identified the gap. He started researching in the engineering education, and he authored a textbook along with the 3 other authors from Sweden. And that book is nothing but the CDIO approach, rethinking engineering education. There actually you can see how the students should think like Von Karman and perform like Thomas Alva Edison. So this is how the CDIO was evolved. CDIO was evolved over the period of time. Now you see, once again, for the clarity, I am showing the graph. The y-axis, Thomas Alva Edison, innovation, implementation. Not only designing, we have to implement. Then collaboration skills, then practice. The 1950, only these dominated. There is no much disciplinary knowledge. But when time period goes on from 1950 to 60, science and 80, science dominated, and now we are teaching only the science to the students, especially in India. There is no the practice-based students are not really doing the practical sessions and not developing the projects or problem. They are not really solving the the problem, trying to provide a solution for the societal problem or the industrial problem or the domestic problem. These are all the issues. Then what happened, now we are seeing the right hand side, the book by Edward Crowley, John Malquist, and the Wostad and this Christiana. So they are the authors, rethinking engineering education. Now, what happened, Now, yes. As I told earlier, think like Von Karman and perform like Edison. So now we need both disciplinary knowledge as well as practice. The CDIO was founded in 2000 by the 4 institutes, and they are trying to provide these 4 CDIO to the students. Right? What are all the challenges and opportunities for engineering education? Now, to impart the good education, engineering education to the students for the country or as an institute, what are all the challenges? Say the problems are multidisciplinary in nature. But actually the globalization is required. The problem is not the local, it is the global. Then we must provide the sustainable solutions for the problem. And we have to use the new technology and services. And we have to enterprise the things, entrepreneurship. And these are all the issues and the skills. What are all the skills required? We need the design skill, innovation skill, communication skill, teamwork skills, and the personal skills like creative, ethics, and so on, the personal skills, and again the constraints. So these are all the problems to be addressed, and these are all the the skills required, and what are the constraints and resources? Prior knowledge is the constraint. We understood that engineering is completely different. What is required? So where we want to be, we are not. So the prior knowledge is because I am teaching my students the way in which I was taught when I was studying, and how I learned. The same way I am trying to teach my students. The prior knowledge is the hindrance. So if you read the book by Susan Ambrose, how learning works, and how the prior knowledge is really acting as a hindrance for vis-a-vis implementing the vis-a-vis facilitating the students learning, you will come to know. And the second one is the faculty competence and time. Say, nowadays the faculty are overloaded with the nuisance and nonsense works. Say, as a faculty, I would say, they are working, they are doing the clerical jobs. They don't have time to acquire their teaching skills or enhance their teaching skills. They don't have time to really acquire the disciplinary knowledge, to acquire the practical skills. So really they are suffering like anything. So the faculty, to enhance the faculty competence, what institutions should do. And these are all the challenges. I would say the constraints are the resources. Then digital tools and learning. They will tell now, even today, through virtual means, we are delivering the things. And a lot of, even the proctoring software is there. And there are so many ways to do the analysis, and so many while delivering the content, immediately we can assess what extent the student learn. There are, but institute, they will not go far. Buying and doing that. Why should I do? Why it is required? So these are all the constraints and the resources. So yeah, these are all the challenges and opportunities for engineering education. And the central questions. So these are all related to CDAO only I am talking. Don't think I am talking something different, new, because to implement the outcome-based education successfully for your program, CDAO is the suggested way from my side. So far, I am telling what is CDIO and how to implement. That only I am discussing. What CDIO is telling, CDIO, there are three central questions. Say, what is the first question? What is the professional role and the practical context of the professional? Say, it is nothing but professional role. When they will do the professional role, when they will play the professional role after graduation, and the practical context of the profession. Say they have to face a lot of challenges. Say that what is the professional role and the practical context of. So normally in outcome-based education, these are all nothing but the needs of the constituencies, needs of the stakeholders, in the sense what our graduates will achieve within few years of graduation. Nothing but the program education objectives. And here the CDO also, they are telling what is a professional role. And the second question is, what knowledge, skills, and attitudes should the students possess as they graduate from our programs? Say it is nothing but the program learning outcomes. Program outcomes are the graduate attributes. What our graduates will do upon completion, what abilities they will have, what abilities they will demonstrate. And the third question, how can we do better at ensuring that students learn these skills? Say, need we understood, and what knowledge to achieve the need, what knowledge that also, or to fulfill the need, what knowledge skills we identified. After that, how we are going to ensure these students acquire the skills. So through the curriculum, teaching learning process, and assessment and evaluation, and so on. So these are all the central questions with respect to the CDEO also. And here the professional role, I told you no. So they are telling any engineer will conceive, design, implement, and operate complex products and systems in a modern team-based engineering environment. This is the context. Here, this is the context. Engineers conceive, design, implement, operate complex products and systems in a modern team-based. Modern team-based means individually they cannot do the project. They will work with the teams of the different people from different culture, different country, different disciplines. They should discuss with the electrical engineers, should discuss with the economist, electrical student will discuss with the computer scientist. Say, so modern team-based environment to solve the engineering problem, and that are in the complex in nature, and they may conceive the new idea for developing the new product, or the idea may be existing and they will concentrate on the design, or the design may be the existing and how to implement the design to develop the product or fabricate, or they conceive design implement part is there, how to really use or operate. So any one of these four or any two of these four, only the engineers will do normally. So this is the professional role of engineers as per the CDIO. And the context for the CDIO process. What is the context for the CDIO process? Say, as I told, conceive means what is the meaning? Say, life cycle of your product, process, project, system, software, material. Life cycle means from fabrication to disposal. From fabrication to disposal, and again the cycle should get closed. That is called life cycle. Say the life cycle of a product, because sustainability matters a lot. So the life cycle of your product process. Conceive. How to conceive the, say example, I want to climb the tree. I want to climb the tree. There are so many ways to climb the tree, right? So here the customer needs, based while conceiving the new idea for the new problem or the challenging problem or the open-ended problem, while conceiving, we should consider the customer needs, technology, enterprise, strategy, regulations, and the conceptual, technical, and the business plans. You see, nowadays, are we considering all the things while trying to provide a solution for one engineering problem? Definitely not. We are trying to solve the problem. We don't bother about whether they say, you see the pen, how many different types of pens. You see the mobile, how many different types of mobile cases you see, how many different. So that can, because every customer needs a different, kind, each one taste and the requirement will be completely different. So if you see that, again, the technology, whether all the mobile phones are using, or simply you take the pen, whether all the pens are using the same technology? No. Say they are telling this is gel pen, this is ink pen, this is that pen, and the holding that different. Say, and if you take any electronic product, because for that matter, mobile is the best technology. All the mobile phones are using the same technology. Definitely not. Enterprise strategy. Once if you are thinking while doing the how we are going to enterprise the things, and the regulations. Say how much amount of radiations are permitted, beyond which that will not be permitted, and which country, and what kind of name we can keep, whether it will affect their sentiment or something, their culture, and all the things we need to consider, conceptual, technical. So again, design. Engineers should develop the plans, drawings, algorithms that describe what will be implemented. Say while designing, we need to consider how we are going to implement. Suppose if you are developing some new design after conceiving, say example, you are going to develop one product and you are telling my product will be like this based on these needs and all everything, and you need to design. Design means plans, drawing, and other things using the software, CAD or CAM, whatever it may be, something or algorithms. Okay, then implementation. After designing, we have to fabricate. Well, we have to develop the if it is software product, whatever it may be. So the transformation of the design into product, process, or system, including manufacturing, coding, testing, and validation. Operate the implemented product or process delivering the intended value, including the maintaining, evolving the and retiring the system. Say the life cycle, how we are going to dispose, right? So engineers, actually the context for engineering is the CDO process. The first one I told, and this is what is C, what is D, what is I, what is O. Okay, this we are telling as the needs, the role of engineer we told, and they will work in the modern team-based engineering environment to develop the complex product by conceiving, designing, implementing, and operating. Okay, fine. And what is the full set of knowledge required? what is the full set of skills, and what are the attitudes. Say in outcome-based education, they are telling 12 graduate attributes. So whatever you want to do in the program, you do in the program. But finally, we will measure only that these 12 they are telling. Likewise, what CDO is telling, whether CDO, just before I told the CDO will help to implement the outcome-based education successfully. So here, whether what knowledge, what is the full set of knowledge? We have to clearly tell the cognitive domain, psychomotor, affective domain, all the things. So when the students are graduating, what abilities they are supposed to possess. Then, after identifying the full set of knowledge, skills, and attitude, at what level of proficiency, means the knowledge means whether it is the applying level, or analyzing level, or evaluation level, or creation level, creating, or if it is the skill domain, whether it is the imitate, manipulate, articulate, naturalization, there are different. So imitate, manipulate, precision, articulation, naturalization, there are 5 different levels, which up to which level. So what level of proficiency, if it is a affective domain, whether it is a receiving level, or responding level, or valuing level, or organizing level, or characterization, or internalizing. So which level of proficiency? And next, in addition to the traditional engineering disciplinary knowledge, say you see, in addition to the traditional engineering disciplinary knowledge and the skills, other skills, personal, professional, interpersonal, then the CDO skills. Let us see in the next slide. This slide shows from underlying need. Need we have seen. What are all the need? So the need, actually the students CDIO we told, right? From underlying need to program learning outcomes. So how to go? We need to educate the students who understand how to conceive, design, implement, operate complex products and system in a modern team-based environment, and are mature and thoughtful individuals. Now I am correlating. Understand how to conceive, design, implement, and operate. That is a process. Number 4, the CDO skills. Complex products and the systems. So you see the disciplinary knowledge. In a modern team-based engineering environment, it is nothing but the personal skills, and are mature and thoughtful individuals, nothing but the interpersonal skills. You see, say how the what do you call the underlying need is codified with four items. One is the disciplinary knowledge, second one is the personal, third one is the interpersonal, fourth one is the CDIO. So we need to see this is a first level. Next level we will go. This is the next level. So CDIO syllabus, because I told, so the full set of knowledge, skills, and attitude we have to tell. The first level over, second level you see the disciplinary knowledge and the reasoning is the first level. Further it is divided into 1.1, that is knowledge of underlying sciences. 1.2, core engineering fundamental knowledge. 1.3, advanced engineering fundamental knowledge. So this is the first level, and 1.1 is the second level. And second thing, if you see the from the need to learning outcome, second level, second one is personal and professional skills, and the third one is the interpersonal skills. Fourth one is the CDIO, complex conceive, design, implement of complex systems, implement and operation of complex systems. This is the second level. Second level means what I would say from 1, 2, 3, 4 to 1.1, 1.2, 1.3, and so on, and finally the 4.6. Next level, if you see the yes, some in between some disturbances. Why I can yes. Now you see, this is a third level. How further you see, 1, 2, 3, 4, the blue color, they are in the first level, and 1.1, 2.1, and 3.1, and so on are in the second level, 2.1.1, 2.1.2, 2.1.3, third level. You see, compared to the graduate attributes of washing a car, how it is further percolating, the third level. Now you can see the fourth level, CDIO syllabus. The complete the first level, second level, third level, fourth level, all together called the CDIO syllabus. In the fourth level, you can see the Bloom's action verb. Say, if we take the second one, personal and the professional skills and the attributes, there the second further, if you break down 2.1, that is the analytical reasoning and the problem solving. Then further, if you break down, that is a problem identification and formulation. Further, if you break down using the Bloom's, under problem identification and formulation, students should be able to evaluate data and the symptoms. Students should be able to analyze assumptions and the source of bias, and students should be able to examine. Say this much level, in addition to the disciplinary knowledge, they are telling personal and professional skills. Third is interpersonal skills. Fourth one is the CDO skills. And compared to only the 12 statements of the Washington Accord graduate attributes, if you see the complete syllabus for the engineering education, what to teach, the CDO syllabus will clearly tell what to teach to the students, or what kind of what students should learn. That CDO syllabus will tell very, very clearly. Even if you go through the book and this rethinking engineering education, the CDIO approach, you will come to know the detail. Otherwise, also, I am recommending you can go to the CDIO website, cdio.org. You will come to know. So the 4 levels. So that actually graduate attributes only 1 to 12. That's all. They are telling whatever you want to do in the program, you do. But here it is not the case. How to really design your syllabus, how to design your program, how to design your program. So what level your students should learn, how to keep the content, for what you have to give the importance. You can see, you may ask, sir, how can you say this is a standard one? The CDO syllabus you are showing, just I have shown the sample only. I did not show the complete what is the CDO syllabus, and just the sample. And if you see, you can ask, sir, how can you say this is acceptable by all the stakeholders and this is a standardized one? Just a minute. Hello. Hello. Yes. Sorry, I received a call. Here you see this actually the syllabus which was developed by an international expert team of more than, I think, actually the people from so many countries and so many institutions, which was validated by different stakeholders through interviews, focus group discussions, surveys, peer review, and through conducting workshops and roundtable conferences, roundtable sessions, and this was validated. Here, the students, here the stakeholders, I can say, why the slide is not moving. Yes. Validation of the CDO syllabus, the stakeholders. Say in MIT, I am explaining only one sample. The 6 groups surveyed, first and fourth year students, alumni, 25 years old alumni, 35 years old, 25 years old alumni, 35 years old alumni, faculty, then leaders of industry. Say These are all the stakeholders participated in the validation process and the question for each attribute. So I have shown the syllabus, CDO syllabus, 1, 2, 3, 4, disciplinary knowledge, personal and professional. Then third one is interpersonal, fourth is CDO. Then under the second level also, I told 2.1, third level 2.1.1, and then with the Bloom's action map. It is a very exhaustive one, and if you see here, they have set the scale like this, some 6-point scale, and here for better clarity, I am moving a 5-point scale. Initially, yes, later they evaluated. Now they are using the 6-point scale to assess that this is the old survey report. Here, to have experienced or been exposed to, or that is one. To be able to participate and contribute, just this experience or been exposed to be able to participate and contribute to be able to understand and explain, to be skilled in the practice or implementation of, to be able to lead in the or innovate in. So these are all the scales student will rate 1, 2, 3, 4 and so on. Say they are not students, the stakeholders will rate, including of course students, graduating students. Now if you see in the MIT, this is this survey, the stakeholder survey, or I would say the validation at the second level of CDO syllabus. Second level means say 2.1, 3.1, 3.2, 3.5, 4.2, 4.3. It is not further down. So further third level it is not done, fourth level. But in the second level when it was done, so getting the feedback from the OBE, and they started developing the new curricular framework called the CDO initiative. And the CDO syllabus they developed, and they are validating with the different stakeholders. And here you see the students in the MIT, the exposure level, it is lowest level, second participate, third understand, fourth skilled, and the fifth one is innovative. With respect to system thinking, they are this much level. With respect to engineering reasoning, they are the highest level. For the different stakeholders, faculty, industry, alumni, it is called what is it, old alumni and the new alumni, the young alumni. Y is young alumni and Y is the old alumni. So here, if you see that, if you take the alumni, their response here, the alumni, the old alumni, they are very poor in business context. They are very, very poor in social context. Even faculty also, they are very poor in. Then say the industry stakeholders. Say if you see, the thing is, this is the true picture. The Massachusetts, conducted the survey. They told very clearly, this is actually the societal context, business context, all the things, and the remarkable agreement. So what when this was validated, yes, they all agreed, yes, it is true. Students who graduated from the Massachusetts, they are not good in what do you call the business context or social context. Of course, sometimes the what do you call the system thinking also, sometimes they are lacking, and conceiving, so to some extent, okay, designing they are very good, but implementing they are very poor, and operating also they are very poor. So it is actually the validation process, not only with the only one stakeholder. I am showing only one sample, and validating with the different accreditation framework. Say in USA, ABET, Accreditation Board of Engineering and Technology, actually they have their student learning outcomes, SLOs. Previously, there were 11 outcomes, A to K. Now only the 8 outcomes, student outcomes, SOs. And they are trying to map the CDO syllabus. CDO syllabus are nothing but the detailed outcomes required for the engineering program. So they are mapping the CDO syllabus, the learning outcomes with the engineering accreditation graduate attributes, or I would say with respect to ABET, it is called student outcomes. Then Canada Engineering Accreditation Board, Canada, and Europe is then the CDO syllabus, which was developed and experimented, tested, fulfilled the requirement of all the international accreditation agencies, including ABET. Say these are all the findings. As I told earlier, the Boeing, once again, for the clarity I have kept, See, 1995, what actually the Boeing suggested, the gap, identified a gap between the industry expectations and the MIT graduates were, what to say, were fulfilled through this means. And this is not only for MIT, they tested with so many institutions across the globe in Asia, Singapore, Malaysia, all the countries, almost more than 200 institutions later participated with almost all the institutions that, and it got evolved. It is not the standard fixed framework or the reference framework which was developed in 2000 or 2005 or 7, and every year it got evolved, and nowadays actually the version 3.0 has come, and you can see in the CDAO website. And say CDAO, in what way this will help the program? CDAO tells very clearly the learning outcomes. Say the learning outcomes, the first level, if you see the only 4, and second level, each, what to say, the major learning outcomes are broken into, sometimes the regulatory calls may come. Hello. Sir, I'm delivering a webinar online and to some institute. If you don't mind, can you call later? Can you call me later, please? No, after 5 something. Okay, fine. I'm delivering. Okay, okay, please. Okay, fine. Say, fine. The syllabus, if you see the detailed outcomes, say graduate attributes are only 12 statements, but here if you see, you can see more than what to say 200 statements you can see. So the 200 statements are the learning outcome statements, and which will clearly tell what knowledge, what skill, and you don't need to adopt all the 200 learning outcomes, and based on your requirement you can customize, you can keep, you can select, you can drop, but you cannot drop below the requirements of your accreditation agency. So this and what to teach to the students, CDO syllabus will tell clearly, and the CDO syllabus is telling, and how to do, what to do, what to teach, then how to teach, how to implement, how to ensure the students are acquiring these learning outcomes. How can you demonstrate the students are attaining this learning outcome? Then there are 12 standards. The 12 standards of CDAO tell very clearly how can you ensure, how can you really facilitate, how can you really implement the CDAO syllabus in your program. So the 12 standards, first is the CDAO as the context. First, actually, we should all agree. CDAO context is in the sense, actually, engineers conceive, design, implement, operate product, process, and systems in a complex system in a modern team-based environment. That once if we agree, then we will go what? CDAO syllabus will tell what to do, what to teach, and CDAO standard. This is standard 2, and standard 3. Standard 2 is actually CDAO syllabus is nothing but the complete learning outcomes. And how the CDAO standard 3, integrated curriculum. Your curriculum must be integrated. What does it mean? Your curriculum should have, in addition to the disciplinary knowledge, other components, personal, professional, interpersonal, CDAO, all the things should be embedded. You cannot teach them individually. And if you see the introduction to engineering, then if you see this is the 4th standard. 5th standard is design, implement, and your introduction to engineering means we should give the students a flavor of engineering when they are in the first year. When they are in the freshman year, we have to give them the taste of engineering. Students should feel, yes, I like engineering, I love engineering, I will stay back in engineering, I want to become engineer. Say to have that to give them feel and flavor, definitely we should do some kind of introduction to engineering things, to activities to the students. And the 5th one is the design implement experience. It is a standard 5, and it may be the 2 level standards. One is the basic level in the 2nd year, and another one is advanced level either in 3rd year or in the 4th year we can keep. And the workspaces, engineering workspaces, to do the design build experience we need engineering workspaces or engineering learning workspaces And then we have to impart the knowledge and knowledge and skills to the students, through active and experiential learning, and using the integrated, providing them the integrated learning experience with the experiential learning and active learning, like jigsaw method, think, pair, share. I would say the mudguard method, and even peer instruction and a peer involved. There are different active learning methods: a collaborative learning, cooperative learning, problem-based learning, project-based learning, challenge-based learning, different kinds of learning, active learning methods. And if you see the assessment, then we have to measure the attainment of the learning outcomes which are defined in your program, referring the CDO syllabus. After making the assessment, we have to go for the faculty competence, because to deliver the content, the faculty should know what is active learning, how to really deliver the content, and they should know how to really facilitate the students to acquire the skills. Once if they demonstrate the skills, then only they can help the students to acquire the skills. So faculty teaching competence and faculty the disciplinary knowledge. So one subject knowledge and the teaching knowledge. These two are important. So two standards, 9 and 10. The active learning is one, integrated learning is one. So 7 and 8, there are two standards. And the last one, if you see the how well we are doing. So we have to evaluate the entire program. We have to measure all the 12 CDO context to the 11, the assessment. All the things if we measure, then it is nothing but the program evaluation. We can measure the quality of the program. So the 12 standards of CDAO clearly tell what to do in the program, how to do in the program, what to teach. CDAO syllabus will tell how to do. So the CDAO standards, each standard will tell very clearly the rationale behind the standard and how to really implement, how to develop the integrated curriculum, how to do the introduction to engineering to the freshman students, how to really develop the faculty, how to develop the faculty with the teaching skills, and how to impart the training to the faculty members to facilitate the guide the students learning. All the things are really the wonderful, all the CDO standards if you see, and the connections. Now the integrated curriculum is nothing but it is nothing but the introduction to engineering with the integrated learning experience and active learning. These together called the integrated curriculum, right? And if you see the what is the integrated learning experience to the design to build experience, to do the design implement experience or design build, the workspaces are required, and this faculty competence is required to really provide the students design implement experiences, and the students to spend time in the workspaces, and the faculty competence is required to really implement the active learning and the integrated and experiential learning. So yeah, and how well the program is doing the things or adhering the CDAO standards in the sense, again the faculty will measure. So these 12 standards really will tell or help the program faculty and other stakeholders to implement the CDAO syllabus in the program. And what is the 12 standards? I will explain. The context, adoption of principle, adoption of the principle that product, process, and the system, life cycle development, and the deployment. This is a context first. Say CDO context we need to understand. Then the learning outcomes, the second one, nothing but the CDO syllabus complete, integrated the curriculum designed with mutually supporting disciplinary subjects with an explicit plan to integrate personal, interpersonal, and product, process, and system building, CDO skills. So introduction to engineering means provides a framework for engineering practice in product process. Then in the first year we have to give them design build experience. One is at the basic level and another one is at the advanced level. And engineering workspaces. The sixth one is the engineering workspaces. Seventh one is the integrated learning experiences and active learning. 8th is enhancement of faculty skills competence. 10th is enhancement of faculty teaching competence. 11th is learning assessment. And the 12th is the program evaluation. These are only 12 standards of CDAO. And 2-3 standards actually in which I have done the extensive research that I will touch upon. They integrate the curriculum. How to integrate the curriculum with the personal, interpersonal, and CDO skills. And now you can see some samples of here. This is not my original one, and this I have taken actually Professor Christiana, who did her research in KTH Sweden in the vehicle engineering program, and there actually the 3 years program. In Europe, the engineering is a 3 years, because after 13 years of school education only they will go for the higher education. So 13 plus 3, 6, we all know very well. In India, 12 plus 4, 16. So for them, the engineering higher education is only 3 years. So how they are integrating the different skills in the program? Let us see. Say now the written communication through what we call the maths, through the physics, through numerical methods, through thermodynamics, and finally the bachelor thesis. Through 5 different courses, they are they embedded the written communication, and they are imparting the written communication, and they are assessing the written communication skill. And if you see the communication in English, say here I would say the course, which one? The introductory course 1, then the product development something, then another course, the bachelor thesis. Through these 3 courses. Say likewise, we need to develop the integrated curriculum. I am not telling the integrated course. Integrated course is different from integrated curriculum. Curriculum must be integrated in nature. Course integrated means, so take only one particular subject. There we are, what to say, bringing some practical component and other skills. Then it is called the integrated course. So here curriculum must be in the integrated nature. Then if you see the design build experience, this is another one standard. There actually in Chalmers and KTH, Chalmers actually, to provide the students the design build experience, they introduced the formula card. And there the students of Chalmers, they developed this thing, and KTH solar driven aircraft. So one must be in the design build experience on the basic level, and another one must be in the advanced level. In second and the third year, or third and the final year, we can provide this kind of experience to the students. And here, these are all the different spaces which are in the engineering workspaces. If you see the engineering workspaces, here the students they need the concept forum, means to discuss, to brainstorm, and the design center, and what is it? They here the conceiving, for designing, the implementation lab, in the sense some studio, or all the off-the-shelf components, from the off-the-shelf components, all the engineering testing and fabrication facility kind of fab lab, everything, and operations means to test and everything, all the things should be. So in addition to this important 4, and there should be space for storage and the network, and again the learning resources, social space is of course definitely required. So these are all the student workspaces for CDAO. And the space in MIT, you can see the CDIO space alone I am showing. And here, this actually I established in the institute where I previously worked, the Weltech Institute. There I established the conceive, design, implement, operate. This is the first university from India to become the member in the CDO worldwide initiative. And you can see the facility students, the first year students, they will develop the product. And this again, the inside, this is the outside, and this you can see the inside, how the students are, this conceive space and design space, implement, operate, and so on. And here I would like to summarize the CDAO aims. Actually, here the another one standard, the integrated learning experiences. Say active learning is another one standard. Integrated learning experiences, in the sense, actually the communication skill, team working skill, ethics, sustainability, all the things we have to bring in addition to the disciplinary knowledge. So that is actually when they are learning, when they are acquiring the disciplinary knowledge, all that they should have the feeling of the integrated learning experience, in the sense they are improving their communication skill, teamwork skills, and so on. So the integrated learning experience that is required, and this is the learning space which I created. This is another one standard of the CDAO, the standard 8, active and experiential learning. Here the active learning space with the clickers, you can see the students actually they will discuss, and they will keep the they will carry the clickers once the topic is delivered. And if I want to assess students what extent they learned the things, immediately from the students' response, I can learn. I will come to know, and accordingly I can change the delivery method. And finally, I would say the CDIO. I just presented only the 0.1% of the CDIO, because the CDIO worldwide initiative was started in the year 2000, and now 21 years have gone. Today, the 17th International Conference on CDIO is going on. So, what I can say, this is actually, it got evolved over the period of time, and a lot of students' involvement, and faculty involvement, and institutes involvement, and volunteerism, and the Tyagaraja College of Engineering in our state became the second institute which joined in the CDO initiative. I personally helped them in the sense, actually, there they are doing a lot of educational research. Dr. Bhaskar, Dr. Thiruvengadam, and a couple of senior faculty members who are doing educational research, they took the initiative for their institute to become the member in the CDO Worldwide Initiative. And here, what I want to convey, this is CDO is not the prescription; it is a reference model. You no need to worry. No, this and all. How can I do for my program? How can I convert my existing program into CDIO program, and now itself to implement the OBE, I am struggling. No, to implement your outcome-based education successfully, only I am suggesting the CDIO. Once if you follow the CDIO syllabus and the standards, definitely 99% not, I would say more than 100%. Say what OBE is expecting, what Washington Accord is expecting, what NBA, National Board of Accreditation, is expecting, your program will deliver much more beyond the expectations of the accreditation agencies and expectations of the various stakeholders like students, parents, or the industry, or the student employers, or the society at large. Say, I would say the CDIO is the curricular reference model which will help the program stakeholders to implement the outcome-based education successfully for their program, and to ensure the students attained the learning outcomes which were set before commencement of the program, and subsequently to attain the program education objectives, means the career, professional and career accomplishments of the graduates, in the sense what our graduates will achieve within few years of graduation. And the concluding remarks, an idea of what engineering students should learn. Engineers who can engineer. This is the idea. This only the CDO is telling. A methodology for engineering education reform, CDO syllabus, and 12 CDO standards. We have seen the 4 different levels of CDO syllabus. First level, second level, third level, fourth level, and the 4 different, the headings, the first level. Say again, CDO is the community initiative. Now more than 200 institutions. So it is based on, I think, 2007 or 8. So only 107 universities were member. Now more than 200 institutions are member from different countries all over the world. And this is actually the, if you want to learn more about the CDIO, you please refer the book Rethinking Engineering Education, what I have shown, or you can go to cdio.org. Yes, it is available. This is the 4th international, which was held in Kanazawa, Japan in 2018, 2019, 15th, 2020, 16th virtual conference, 2021, 17th one, which is going on. Today also it is happening. I think by tomorrow it will get over. And these are all some of the resources to know more about the CDIO. So thank you very much for your patient listening. And if you have any doubt or any queries, you can ask.
Thank you, sir. Participants, you can unmute yourself and ask questions, or else you can post your questions in chat box. We can discuss now.
I am seeing the chat box. If anything is there, feedback link, something. As of now, no. Good afternoon, sir. Good afternoon. Nothing.
Participants?
If you have if you have any query related to outcome-based education, sir, it is useless. If you want to comment, you can comment. I will tell in what way this will be useful. Because until unless we really do and implement the things, we cannot criticize. I have been experimenting. I have been implementing. I have been observing. I have been inferring so many things from what to say the implementation and trying to find out the ways and means to bring the continuous improvement in the overall academic process. So, if any of you have any doubt or anything related to this, you can what to say ask, or you can write to them, and the madam can send to me. And if time permits, definitely I will address for your queries.
Hello, sir. Good afternoon, sir.
Good afternoon, sir. Yes, please.
Hello.
Yes, sir. I'm hearing you.
Regarding for implementation of CDO, for implementation of this CDO concepts, what you said, sir, practically it is essential, and as you shown everything, it's how it is evolved. In our India, is it the institutions to implement? Is it required to collaborate many of the industries, with core industry, especially for the programs?
Fine. Sir, it's a very, very valid and relevant, important question. I'm very happy. I'm telling this is the reference model, sir. Here, what I'm suggesting, as of now, we are not following any kind of model, right? In the name of OBE, as I suggested earlier, some kind of only the documentation we are doing, but really we are not practicing. So if we adopt ADOPT, if we adopt some model, and no need to complete, no need to fulfill all the components of the CDEO. You take only one or two standards. You try to achieve the two standards. Say example, I will tell the active learning standard. You take standard 8. You try to identify the faculty members in your program, some few faculty members. Otherwise, you yourself, you try what are the different active learning methods. So what subject you are teaching? You belong to which program, sir?
Sir, I am from electronics and communication engineering background.
Say
sir.
example, you are from electronics and communication. What course you are teaching, sir? What subject?
I am teaching for microprocessor,
Say
microcontroller,
example, if you are
embedded
teaching,
systems.
fine. If you are teaching microprocessor, microcontroller, say microprocessor, when you are teaching, say there the practical components are there. Say example, if you are teaching 8255, say PPI, or 8257, or 8251, or 8279, or 8253, there are different chips. And when you are what to say delivering the concepts, that time you are taking the students to the lab, and you are asking them to what to say do some experiments, and these are you are providing some hands-on to the students. But if you follow some kind of active learning methods like jigsaw method, think pair, and experiential learning, peer instruction, or flipped classroom or something, blah blah blah, for the microprocessor course, the same course, so many other professors in the different institutes or different countries might have tried the different methods, and referring those methods, if you try the active learning methods, definitely your students learning will be much better, and they will be very happy. More than them, you will feel more happy. Say, and the learning of the students will improve a lot. Say, first, what I'm doing, you forget about all the 12 standards. No. How it comes possible? You take only one standard. Otherwise, you take the design build experience. Say for your microprocessor program, some kind of small projects, say activities. If your program, if your institute is a autonomous institute, then you can give some credit also to develop some project in the microprocessor. Some what to say 1 credit. Otherwise, some assessment you can consider that project. So you can give them some mark or something, even if not a full credit. Some kind of things. If you then the design build experience student will get. This is another one standard of CDIO, and you go through the learning outcomes of the CDO syllabus. So then some of the learning outcomes you can take personal or interpersonal, professional, something you bring into your course, and you try to what to say impart those things to the students and try to measure. Then it is good. It is more than enough. Say what I'm trying to say. It is very, very difficult to bring even a small change in the existing academic process in India. I'm telling, because nobody, including myself, don't want to work. Nobody, including myself, want to work. That is a problem. The thing is, want to work in the sense, I studied, I did my PG, I guided this many students, PhD, this. With this knowledge, I will teach the courses, I will go. That's all. I don't want to improve my teaching skills. I don't want to improve my research aptitude. Because of this, what will happen, the stagnancy and the students. And I'm telling one thing, recently, the 2-day symposium was conducted by Karnataka State Council for Technical Education and All India Council for Technical Education and Indo-Universal Collaboration for Engineering Education. These three major organizations together, they conducted a RRS PBL Regional Research Symposium on Problem-Based Learning, inviting so many experts from Aalborg University, which is the pioneering institute in implementing the problem-based learning in the world, next to the McMaster University, Canada. That is actually the medical, but here the engineering is Aalborg University is the pioneer university vis-a-vis implementing the problem-based learning since 1984. I personally went to Denmark. I stayed there in Aalborg University for about 5 days to learn how they are delivering. And in India, the problem-based learning, they are insisting now. The problem-based learning we are doing, that is not real problem-based learning. We are not designing our curriculum problem-based or problem-centric or project-centric. But why I'm telling these things, the days are not too far to adopt. They are actually RRS PBL, they delivered the CDO framework. Framework from MIT, Massachusetts. The professor, he presented a new engineering educational transformation curricular framework model. And from Iron Range Engineering, Minnesota, they delivered IRE model. There are so many models, education models, academic model, curricular model, came, evolved. They are following. I agree with you, Professor. It is very, very difficult to bring, but at least actually one should start in a department, 2 faculty, then 2 will become 3, 3 will become 4, 5. You may tell, sir, telling is very easy, but it is very difficult to do. Yes, I, as administrator, I experimented this in 2016-17, and I invited Dr. Balagurusamy, then former Vice Chancellor of Anna University, to assess. Only 14 faculty members came forward to try new teaching methods. Then I started a new forum called Teaching Developers Initiative. Finally, after 6 months, I invited Dr. Balagurusamy to assess the faculty members. Faculty members were very happy. And after that, now that circle, got enhanced. Now, after I left, whether it is going on or I don't know. But the thing is, what I'm suggesting, say the small changes should start from the individual faculty. Then it should like seed. Then it will be noticed by others. They will start practicing, and the student will start appreciating, and you will feel happy and satisfaction because you are following some time-tested, well-proven, internationally agreed, efficient method for students learning. Definitely, it will have its own the value. Thank you.
Thank you, sir. Thanks a lot, sir. Very motivational cards. We do it, sir. Definitely, we'll start, as you said, from first ourselves. We have to start, sir, from myself.
Yes,
then it will definitely
That is always, sir. Here, you believe me or not, I
Thank you,
joined in BS Abdul Rahman Crescent Institute of Science and Technology just 8 months before. You see here, actually, to change the culture, at least I have to spend up to night 8 o'clock or 9 o'clock daily to change the culture. As a director, internal quality assurance, I must work. I must, so it will start from the individual to next level. I have to bring some of the head of the departments to really understand the importance of the innovative curriculum design based on the sustainable development goals, curriculum design based on the key competencies of UNESCO, curriculum development based on the need, curriculum development based on the 20 education model tone, curriculum development based on the Singapore University of Technology and Design. There are so many models. Say I have to make the people to like, to love, to collaborate, to contribute, to innovate. All the things I must facilitate. For that, first I must do it. So then only the change will come. Yes. Any other? Say, okay, I don't want to go to people because actually the participants are leaving the meeting.
Yes, sir.
I don't want to, because as per the schedule it is from 2 to 4.
Yes, sir. Yes,
right?
sir.
I
Now,
don't want to take much of your time, and
yes.
I take this opportunity to thank the coordinator and the convener of this AICTE sponsored faculty development program, Dr. Gladys Madam, and principal sir. I came and met him sometime before. Then that time he was vice principal. Now he is principal. Dr. Soundarajan sir, madam.
Yes, sir. Yes, sir. Now Dr. Soundarajan.
Yes, Soundarajan sir. And when I came that time, he was vice principal.
He was vice principal. Yes.
Vice principal, and I must thank Dr. Sugumar. So, Sugumar, somebody, his name.
Yes, Sugumar,
Computer
sir,
science
HOD.
HOD.
HOD, yes, sir.
HOD, yes. So, and yes.
I should thank you, sir, actually, for your busy schedule. You came and gave a wonderful lecture. And because behalf of Velamal Institute of Technology and the Department of Computer Science and myself, I am expressing my hearty thanks to you, sir.
Thank you, madam. Thank you very much.
Yes, sir.
Right?
Yes, sir. Thank you, sir. Thank you. Thanks a lot.
So, shall I leave?
Sir, you can leave, sir. You can leave.
I can leave. Okay. Thank you very much.
Thank you, sir.
Have a nice time.
Yes, sir. Yes, sir.
Stay safe.
Yes,
stay
sir.
healthy.
Yes.
Stay
Yes, sir.
strong.
Yes, sir.
Okay.
Sure, sir. Thank you, sir.
Thank you.